All right, everybody, welcome to this video in which we are going to be discussing content from section 8.12 of AP Calculus volume with the washer method, revolving around other axes. This is going to be the last section for AP Calculus AB. Congratulations, when you're finished with this section, we have reached the end of the course. For those of you who are taking AP Calculus BC, we're not at the end of the course yet. In fact, we have 24 more sections to go after we've finished this one. But we're getting close. All right, so there's not really any new information or thoughts for us to discuss in this lesson. Like, basically, we're taking the last two sections, section 8.10, where we learned how to revolve a region around a non-axis with the disk method, and section 8.11, where we learned the methods for using the washer method, and we're combining those two things into one scenario. We need to, when we're talking about going around a non-axis, we need to consider the distance from the boundary curve to the axis of rotation as our radius of revolution, and then in part two, as far as the washer method, we need to consider ourselves working with the outer radius and the inner radius of the solid. So this lesson is going to be all about examples, and they are all going to use the exact same region. We're going to take this region that here in example 1, it says find the volume of the solid generated by revolving the region bounded by the curves y equals 4 minus x squared and y equals e to the x around each of the following lines. And we're going to revolve it around y equals -2. We're going to revolve it around y equals 5. And then we're going to come back next time, and we're going to revolve it around x equals -4 and x equals 3. Okay, so we're taking the same region every time, and we're just going to revolve it around some different lines. So first things first, what I'm going to do in all of these, I've got a picture of the graph, y equals 4 minus x squared and y equals e to the x. One of the most important things that I need to do is write in my intersection points. So we're going to go ahead and we are going to calculate the intersection points here. I'm going to graph these two curves. And so we'll go to our y equals screen and graph y equals 4 minus x squared and y equals e to the x. And we'll graph those two. And we'll find these intersection points. First intersection point, first curve, second curve, lower bound, and upper bound. And I'm going to go ahead and write down both the x and y coordinates of this point right now. This is going to be, I'm going to put these down here. I've got -1.964, 636, comma, 0.140, 20697, and then my other intersection point. Back to my calculator and find this intersection point. And that intersection point is at let's see, 1.058 0064 and 2.880 880 6225. Okay, so those are my two intersection points, and those two intersection points will be the same for parts A, B, C, and D in this lesson. So through the magic of video technology, I'm going to take a moment and pause before we start example 1, and I'm going to put those intersection points on all 4 of these graphs so that I have them for when we get to these problems later on in the lesson. So it won't seem but an instant to you, but I'll be right back with you to talk about example 1. Well, gosh, I don't know what's going on, but I had all kinds of technical difficulties. My screen will not let me write on it unless I'm recording here, apparently. So I'll go ahead and do that in between videos. We'll get that done for C and D, but we're stuck for this one. All right, so first things first, we're going to revolve this region around the line y equals -2. So I'm going to go ahead and draw in the line y equals -2, which is this line right here. Oh, what is going on? Maybe it's not the fact that I wasn't recording. Why is my pen now not working? Interesting. I'm going to go ahead and pause here and see if I can get my technical difficulties fixed. So I'll be right back with you. All right, folks, I'm back. I think I've got my technical glitches fixed. It looks like I can write again on my screen. All it required was, shutting down and restarting a few programs, and all of a sudden things worked again for me. So here we go. All right, so we're revolving this around the line y equals -2, which is this line right here. Okay, this line is parallel to the x-axis, therefore my integral is all going to be in terms of x. So as far as setup goes, this is going to be pi times the integral of, and my left endpoint is going to be my x-coordinate of my lower limit of integration is going to be my x-coordinate of my left endpoint of the region, and my upper limit of integration is going to be the x-coordinate of the right endpoint of the region. And then I need two things, since this is a washer-based solid. I need the outer radius and the inner radius. The outer radius is going to be the distance from this parabola down to the axis of rotation. Now, whenever we're finding the distance between two things along a line, all we're going to do is we're going to take the bigger one minus the smaller one. The bigger one is a point on this curve, a point on the curve y equals 4 minus x squared. And then we are going to subtract away the lower endpoint. So we're going to subtract away -2. And that gives me my outer radius. And I'm going to subtract away what I get with my inner radius. The inner radius is the distance from this curve down to the axis of rotation. So that's going to be e to the x minus -2 as my inner radius. And there's my setup that will work. I could just write this as +2 in here. I could rewrite this integral as 964,636 1.0580064 times, let's see, this is 4 minus x squared minus -2, so that ends up being 6 minus x squared. And this ends up being e to the x plus 2. And so there's my setup. And now I'm going to go ahead and calculate my volume. So I've got pi times the integral of the quantity 6 minus x squared minus e to the x plus 2 quantity squared with respect to x from -1.964636 to 1.0580064, and bada bing bada boom, volume. There we go. We've got 165.477 as our volume for this particular region, this particular solid, 165.477. All right. Let's go ahead and we'll move on to part B. In part B, we're revolving around the line y equals 5. Y equals 5 is up here. So again, this line is parallel to the x-axis. So everything in our integral is going to be in terms of x. So again, we can set up pi times the integral from negative 1.964636 to 1.0580064. And then I need my outer radius and my inner radius. Now, since the axis of rotation is above the region, that means the outer radius is actually going to be the distance from this curve to the axis of rotation, and the inner radius is going to be the distance from this curve to the axis of rotation. Now, how do I find those distances? Again, these are distances along a line segment. So we're going to take the bigger minus the smaller. This line, y equals 5, the axis of rotation, is above the region. And so to find this length right here, I'm going to take the bigger, which is 5, minus the equation for this curve, which is e to the x. So that's my outer radius. And my inner radius is going to be 5 minus the parabola. What's the equation of the parabola again? 4 minus x squared. So it's going to be 5 minus the quantity 4 minus x squared. All of that squared with respect to x. And again, I can simplify this if I want to. I can take what's inside here and turn it into 1 plus x squared, quantity squared. And find my volume of my solid that way. And just copy these limits of integration down, 1.0580064 and negative 1.964636. And now go punchy on my calculator to find the volume of the solid. So I'm going to have pi times the integral of the quantity 5 minus e to the x quantity squared minus 1 plus x squared quantity squared. Again, you can leave this in this form and just type it in as is. You don't have to simplify what's in the integrand in order to type it in. In fact, I normally don't. Unless it's something that I can simplify, real easy in my head as I'm typing it in, and then I usually don't simplify it on paper, but I just simplify it as I'm typing it into my calculator. We'll go ahead and do that and see what our volume looks like. 117.227. All right, and there's the volume of my solid. That brings us to the end of the first video for section 512 of section 812 of AP Calculus. We're going to come back with one more video to finish up the Calc AB course. All right, so hope to see you then. Have a great rest of your day. Bye-bye, everybody.